Aye, Captain!
I can't hear you.
Aye, Captain!
Oh.
I'm glad you guys are ready to do more reflections. All right, so now we got a series of some logic problems, and we're going to talk about more things, and it's going to be a great time. All right, so if the pre-image is A at -5, 1, and the image is A prime -5, -1, we're going to describe the reflection that maps point A onto point A prime. So analyzing this, notice how x's are both -5. Notice how the y changed. All right, using the rules up here, which one follows that rule? Well, this would be reflecting over the x-axis. That's where x stays the same and y changes signs. We can write that x stays same, y change sign. All right, some more logic problems. Let's just continue. All right, this one. What's going on here? Well, -4. What? Let me write them on top of each other because this just looks like a chaos. All right, the numbers are changing. They're swapping order. It looks like. Oh my gosh, they're also changing sign. Which one is where you swap order and change sign? Which rule is that? Well, this is going to be a reflection over y equals -x. That's the rule. Pretty cool. All right, neat. Now we got the point P, -3, 7, is reflected in the line x equals 1. What are the coordinates of P prime? This is actually a lot harder problem than it looks like. All right, just a simple reflection, taking a point, reflecting it over a line. But I'm having trouble figuring out what's going on. So let's think about things. All right, I'm going to draw a quick coordinate plane. I'm going to try to visualize this. Y, or, oops, that should be y, that should be x. All right, well, x equals 1. I'm going to say this is line, x equals 1. I'm going to plot the point -3, 1, 2, 3, 4, 5, 6, 7. All right, so what I'm getting at, why I like this problem, is sometimes you're going to have to sketch a really quick picture. All right, this picture is nothing special, it's just kind of a generic coordinate plane, and then I labeled the points. Now, notice how this point is 1, 2, 3, 4. It's 4 to the left, so it's going to be 1, 2, 3, 4. 4 to the right. Well, if I go 4 to the right, that's going to be 5, 7. 1, 2, 3, 4. All right, so that's 1, 2, 3, 4, 5. So drawing a picture, drawing it out, that's going to help me figure out that P prime has those coordinates right there. So just to summarize, P was 4 to the left, so it needs to be 4 to the right. It needs to be equidistant. All right, so that should actually say P prime right there. All right, this problem's a lot more challenging than it looks like. To emphasize that, I got another one. All right, so another way to do this problem, this is drawing a quick picture is how I would do it, but see what I like about math, especially geometry, is there's multiple ways to do a problem. Since it was x equals something, I'm going to focus on my x coordinate. -3 to 4, or -3 to 1 was +4. So then you plus another 4. That's one way to do it. So let's do both ways here for this next one. Notice how it's y equals something. So how to go from 11 to 4, I got to subtract 7. So I'm going to subtract 7 again. So J, 2 will stay the same. I'm going to have -3. All right. So So that's my prediction based on looking at y equals 4, analyzing the y coordinate. Well, that's 7 apart, so I got to do another 7. That's my prediction. Oh, and that says p prime. That should say j prime. Oopsies. All right. Let me just draw a quick picture. I'm a very good artist. If you guys can't tell, I'm probably the best drawing teacher you ever had for math. All right, so j is at 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. J is at 2, 11. Now y equals 4. That's 4 right there. So it's going to be that. Now notice how it's 1, 2, 3, 4, 5, 6, 7 down. So that's a distance of 7. So I have to go 1, 2, 3, 4, 5, 6, 7. And that's at -3 as predicted. All right, another 7. So there's some logic problems like this. When you read the problem, it doesn't seem too bad, then you realize you're not given a graph. So you either have to draw a graph or analyze the coordinates in the line and think about it that way. There are 2 ways to do the same problem, but much more challenging than you think. Okay, let's cruise along. Let's knock this stuff out here, and then we'll save reflection symmetry for the next video. All right. As mentioned earlier, in a reflection, the pre-image and image are perpendicular and equidistant to the line of reflection. So how can you find the line of symmetry if you have both the pre-image and image? All right. The line of symmetry, this is a little hint, will always be the midpoint of the lines connecting the corresponding points in the pre-image. All right, so what does that mean? If I just connect all the lines, V to V prime, W to W prime, and we won't have to do all of them, but notice how like this has a length of 2, so we're going to cut it in half. This has a length of 8, so I'm going to cut it in half to 4. This has a length of 6, so I'm going to cut it in half. It's just connecting all the midpoints. So that's one way to do it. Basically, you only have to do it for one of the points. You don't have to do it for all of them, or even just 3. So this would be the line y equals 1. Remember, it crosses the y-axis, and it's at 1. So that's why it's the line y equals 1. All right. So to overcomplicate it again, or not, I don't know if that's what I'm looking for, but just to be very detailed, I guess, notice how this is 2 apart, so the midpoint would be 1. This is 2 apart, so the midpoint would be 1 apart. This is, how many points? 8 again. So boom, these are all the midpoints really fast of these lines. So the line of reflection would be this one right here. The line of reflection would be x equals -1. Now, truthfully, you don't necessarily have to do it each and every time like this, but that helps you. Sometimes you can tell by looking at it. Now, this looks goofy. I'm going to tell you right now, looks goofy. What's going on here? When the problem looks goofy like this, like I think 1 and 2 are very easy. Clearly horizontal and vertical reflections going on. Some kind of horizontal and or vertical line. That's not that. It can't be anything like that. What's going on? What are we reflecting over here? When it looks goofy, you can choose it's either y equals x or y equals -x. All right, just to kind of steer your direction. Now, I can tell by just looking at it because I'm really smart, but if you're not smart like me, you can draw the lines. See, I don't typically draw the lines because sometimes you don't get nice crisp midpoints, like they kind of fall in the between every now and then. Even like right here, those are the midpoints. But when it looks goofy, you can just kind of tell it's either y equals x or y equals -x. This one would be y equals x. All right. So doing these problems, most of the time you can tell by just looking at it, or you can do some analysis and determine it that way. All right. Stay tuned for more